Okay, on this one, again, I will begin by labeling the angles and sides that I've been given. Angle A is 50 degrees, side A is 10, side B is 20. So, what should I do? Well, I'm going to try to find side B. No, angle B. That's what I want to do. I want to find angle B, this one. So since I have angle A and side A, I can use this fraction. Oops, well, I meant to say A here, but anyway, A is 10, so we'll just write that as 10. There we go. Because that's A over sine A. And then for B over sine B, we'll have to write it like that. So what I just wrote was A over sine A equals little b over sine B. That's what I wrote here. There we go. Okay, so now I'm going to multiply cross this way, which is 10 times the sine of B, and cross this way, 20 times the sine of 50 degrees. And then if I divide both sides by 10, divided by 10. Now obviously 20 divided by 10 is 2, so you could take 2 times sine of 50, or you could just do 20 times the sine of 50 divided by 10. Either way, sine of B equals (1.5320) and then a bunch of 8s. Now, you have to be smart enough to look at what this says. Now, we've talked about what sine and cosine values can be. Remember that sine and cosine both cannot be bigger. They can go all the way up to 1, but they can't be bigger than positive 1. And they can go all the way down to negative 1, but they can't be smaller than that. You see this? That's bigger than 1. So this is not a valid statement. So what do? What this is trying to tell us is that the triangle with these given sides and that given angle simply does not exist. No solution is our answer because this triangle does not exist. Okay, number 6. All right, this is the hard one. This carries over from example 4, where we had to figure out different situations that could exist. So I'm going to start with that. I'm going to start by finding angle B, because I have angle A and side B, and I would then find angle B with these two and then those two. So I'm going to start with A over sine of A equals B sine of B. Okay, so I have 12 over the sine of 35 degrees equals 16 over the sine of angle B. Cross multiply this way, I get 12 sine of B. Cross multiply that way, I get 16 times the sine of 35 degrees. Divide both sides by 12, and I get the sine of B equals 16 times the sine of 35 degrees divided by 12, which gives me the sine of B equals 0.7648. It's at this point that I go, hey, yeah, that's between -1 and +1, so that's good. I'm going to use my sine inverse button to find what B equals. B equals the sine inverse of 0.7648. Now remember that sine is like y, and y is positive, like this number right here is positive, in quadrants 1 and 2. Okay? So, which one is the calculator going to give me? It's going to give me the first quadrant answer every time. So sine inverse of 0.7648 is angle B in the first quadrant, 49.9, let's say. So this distance here is 49.9 degrees. Okay, so that means this distance over here is also 49.9 degrees. So we have an angle here at 49.9 degrees, and we have an angle over here that's not quite 180 degrees. If we back up from 180, 49.9 degrees, we will have this position, which starts here and rotates over to there. That is 130.1 degrees. Okay. Now both of these angles could work in this triangle. That's what you have to understand. The first angle, I'm going to call that B sub 1. It could be 49.9 degrees. It's almost 50. If you add 50 plus 35, you have enough extra leftover space out of 180 degrees total for there to be an actual angle C here, because this is about 50, so 50 plus 35 is 85. So out of 180 degrees, you have some measurement left over for C to B. Does that same thing work if it's 130 degrees? 130, if that's angle B, plus 35 is 165. Yeah, that's still less than 180. So we also, if B is this, we also have some measurement left over in the total of 180 to have an angle C here. So what happens is we now have to say, okay, since both of these angle B's could exist on this triangle, I'm now going to solve this, and I'm going to pretend like there's two different universes of answers. One universe comes from if angle B is 49.9 degrees, and the other universe comes from if angle B is 130.1 degrees. So if angle B, again I'm calling it B sub 1, is 49.9 degrees, then if I take 180, I subtract 35, and I subtract 49.9, I get that angle C is 95.1 degrees. And then if I set it up to find side C, I'd have C over the sine of 95.1 degrees equals B, which is 16, over the sine of 49.9 degrees, cross multiply and solve, little side C sub 1 would equal 20.8. So that would be the answers if angle B was 49.9 degrees. We can also solve this in the same way if angle B is 130.1 degrees. So that would be adding that to this and subtracting from 180. Angle C would be 14.9 degrees. And then setting up again to find the last part, which would be side C. We'd do the same thing as we did up here. Side C over the sine of angle C, which is 14.9 this time, equals 16 over the sine of 130.1 degrees. So this is C over C and B over B. I can find little side C, the second possibility, to be 5.4 units long. So two very different triangles and two sets of answers. All right, so if this is a triangle and you have two sides that are next to each other, so let's say this one is 8 meters long and this side is 12 meters long, and you have the in-between angle, then we have a special formula in this circumstance which tells us the area of the triangle. So the area equals 1/2, you multiply the two sides together, we're using this formula right here by the way, out of the three, times the sine of that angle in between. And you have the area of the triangle. So in this case, that would be 33.94 square meters.